All right, question number 3 right here. It says the diagram below shows a triangle PQR in which the angle QPR is 62 degrees. They tell us that angle PQR is 90 and PR is 11. Find the size of angle PRQ. PRQ. So this angle is what they want right here. So we can call this angle theta. Maybe you want to call it theta. Then what we do know is that this angle theta plus 62 degrees plus they told us that this angle is 90 degrees. We know that angles in a triangle sum to what? To 180 degrees. Since angles in a triangle sum to 180, we can make theta the subject. And so all we need to do is subtract 62 degrees plus 90 degrees from 180. So it's going to be 180 minus 62 plus 90. So when we subtract them, what we get that angle is, again, you can always take out your calculator. If you don't feel confident, take out your calculator and do it. So let's take out our calculator. It's 180 minus in bracket 62 plus 90. So we do that and we get 28 degrees. This is 28 degrees. That's that angle right there. That's the 1 mark. Nice. Okie dokie. Nice. All right. Let's look at the next part right here. It says we need to find the length of the side RQ. This is the length of RQ right here. If we want to find the length of RQ, you can do it any way you want because you have all 3 sides. You can use SOHCAHTOA, you can use sine rule, you can use cosine rule, however you want to find RQ, just depends on you. But what we're going to do is, since this is a right angle triangle, we're just going to stick to SOHCAHTOA and we're going to look and realize that they give us the hypotenuse, right? This angle is 28. And so the side below it is going to be the adjacent. Remember, SOHCAHTOA. So cosine is when you have adjacent and hypotenuse. So what that means is that the cosine of the angle right here, so 28, we know that is equal to the adjacent, which is RQ, over the hypotenuse of 11. So therefore, we can then tell them that R times RQ, the length RQ, is actually cross multiply 11 times the cosine of 28 degrees. And so now we're just going to put that into our calculator. So we put it in our calculator, 11 multiplied by the cosine of 28 degrees. We work that out and we get 9.71. I just want to make sure that my calculator is in degrees. Yes, 9.71. So RQ is equal to 9.71. And you have to put your units, centimeters. You have to put your units, centimeters. And that is the length of RQ. Nice. All right. Now part B, it gives us the diagram and it shows 3 triangles X, Y, and Z on a square grid. So this is a grid right here and it shows 3 triangles. This is triangle X, this is triangle Y, this is triangle Z. Let's hear what they want us to do first. Triangle X is mapped to triangle Y by a reflection. State the equation of the mirror line. So triangle X is mapped to triangle Y. This is X and this is Y by a reflection. State the equation of the mirror line. Now, as you can see, the mirror line is going to be right here. This is the mirror line. which is the x-axis. Yeah, man, this is the mirror line. So this right here, I'm not going to draw a straight line, not so good. This right here represents the mirror line. Why is this the mirror line? Because from here to here are equidistant. From this point here, it's equidistant to the mirror line as from here to here. These are equal in distance. Since the object and the image are equidistant from this line has to be the mirror line. So what's the equation of this line? This line has equation y equal to 0. You might say, what? Yes, y is equal to 0. The x-axis is the line y equal to 0. So that's going to be the equation of the mirror line. Y is equal to 0. Nice. Now it says, describe fully the transformation that maps triangle X to triangle Z. So triangle X is this one, and it is mapped to triangle Z. Now let's have a look at what happened right here. If I were to take a point on triangle X, like this point right here, this point right here is the point 4, 4. This is the point 4, 4. And if I were to look at triangle Z, right, I notice that this is the point where X is now -4 and Y is still 4. So this clearly looks like rotation. It looked like rotation. It looked like we just flip it like this or rotate it. It looked like we turn it. We turn triangle X from here to here. So since we turn it over, it looks like rotation. We just need to find out now what is the angle of the rotation. So since that is what we're trying to find out, all we need to do is remember the rotation formula. What's the rotation formula? Remember, the rotation formula is r of theta is equal to, this is a rotation matrix, cos theta, sine theta, minus sine theta, cos theta. All right, that's it right there. So how does the rotation matrix help apply? The rotation matrix apply because if you want to go from an image point, let's call this point A, to an object point A complement, remember that the image point, always remember, the image point is equal to the rotation matrix times the object point. All right, so the image point, remember, is -4, 4. The rotation matrix right here, we need to multiply it by the object point 4, 4. It needs to give us -4, 4. Now I'm just going to try a random value. I look at it and I say, this look like a 90-degree rotation in the anti-clockwise direction because it's going this way. All right. So what I'm going to then do is I'm going to put theta as 90 just to test out my hypothesis. If I put theta as 90, not just 90, no, but -90, if I put theta as -90, then the cos of -90, let me show you what that would become. The cos of -90, sorry, let me bring up this calculator. The cosine of -90, that is 0. All right, so I'm putting theta as -90. The cosine of -90 is 0. The sine of -90, the sine of -90 is -1. Let's have a look at it. Sine of -90, that's going to be -1. So in this matrix is -1. And then right here is going to be negative the sine of -90. -1 is +1, and the cosine of 90 is 0. Let's check out and see if this is indeed true. Row by column. 0 times 4 is 0. So that would become 0 times 4. Then this would be -1 times 4. Then down here it is 1 times 4 plus 0 times 4. I end up get it. This is indeed -4, 4. So this is true. So this is true. So what can we say? because it turns in this direction, it is anti-clockwise. It is anti-clockwise, and the angle at which it turns is 90. So we say that this is a 90 degrees anti-clockwise rotation about the origin. So let's go ahead and write that down. We can write down that triangle X, I don't like to write out the words. I'm just going to draw a triangle and say triangle X is mapped to triangle Y, to triangle Z, sorry, by a 90 degrees anti-clockwise rotation. And it's a 90 degrees anti-clockwise rotation about the origin. About the origin. That's the center of the rotation. That's your 2 marks right there. Nice. The next part says on the diagram, translate triangle Y using the vector -7, 1, and then label it as V. So we need to translate Y, -7, 1. So let's go around here. This is Y. So we need to first, let's clear up this screen right here. Let's clear off this page. We're just gonna erase a little bit. Let's do some erasing. All right, now that we've erased, let's continue now. So triangle Y, they tell us that this is then translated. So if this is translated, all right, let's use a different color. Let's use black. Remember the translation vector T is equal to -7, 1. So what that means is we move the triangle 7 units to the left. Negative means we move the triangle to the left, and 1 means we move the triangle up. So this is 7 units to the left. So this point right here, which is 0, -2, we move that 7 units to the left. 1, 2, 3, 4, 5, 6, 7. That's this point. Then we'll move it 1 unit up. So then it becomes right here. Now this point right here, which is the point, this look like 6, -2. This is 6, -2. 7 units to the left. 1, 2, 3, 4, 5, 6, 7. And then 1 unit up is right here. Then this point right here now, which is 4, -4. We're going 7 units to the left. 1, 2, 3, 4, 5, 6, 7. And then we'll go 1 unit up, which is right here. So then this is our triangle. Now, I'm not the best when it comes on to drawing these triangles perfect, so just bear with me. It's not wonderfully straight, but it can work. That's our triangle, and they said to label this triangle as V. So this is triangle V. All right, and that's triangle V. Nice. Bruh. Now the next part says on the diagram, triangle X, it says enlarging triangle X about the center by a scale factor of half and label as W. Now this triangle X, we need to enlarge it by a half. Enlarging it by a half, meaning it's each point, we're going to multiply it by half. We're going to scale it down by a half. Let's use a different color. Let's use red to scale it down. So this right here, I have coordinates 0, 2. So if you multiply 0, 2 times a half, 0 times a half is 0. 2 times a half is 1. So that new point will be 0, 1. Now this point is 4, 4. Now look at this. A half of 4 is 2. And so the next point is going to be 2, 2. And then this point right here is 6, 2. A half of 6 is 3. So 3 is right here. And a half of 2 is 1. So 3, 1 is right here. So now all we need to do now is label that triangle. Let's go ahead and label that triangle. Da, 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 da. We want to use, I'm going to use the actual arrows this time. This is our triangle. Da 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 da. This is our triangle now. And this triangle right here is just what they said to call it. They said to call it, I believe they said to call it W. So label it as W. And this triangle is an enlarged triangle X with a scale factor of 1/2. And that's it. So V, this is V right here. W, this is W right here. And that's it. That's 9 marks. Nice.